Hello, everybody. My name is Michael Bolin. I'm here to talk to you about the with keyword, the most evil thing that we've ever seen in JavaScript, according to some people. I'm also the author of Closure: The Definitive Guide, so I'm gonna show you some of the good parts about with, or some of the interesting problems that you can solve with it, and also show you a little bit of Closure as part of that. So first, let's just remember what people are saying about with. So some of our most popular JavaScript books, they're basically saying, don't even look at this thing. This is the with keyword. It's going to slow your program down, and you're going to have errors if you use it. Like, let's move on to the next section. Usually, when you see someone give an example of what with is used for, it trivializes it considerably. It basically says, oh, you're probably a lazy programmer, and if you want to add a lot of properties to an object, you're using with, you put the object you want to add properties to inside there, you do all these things inside the block. Whereas you could also just do what I show on the bottom of this slide, where just create a temporary variable, and then do the assignments that way. So basically, the argument is that you really never need with. With is actually doing a lot more. It adds another object to the scope chain for when you're resolving variables. This actually lets you do a lot more interesting things than this little example that is what you usually see about with gives it credit for. So let me show you a problem that we had in my last job that we actually only seem to be able to solve using with. So this is actually a snippet of code from Bing Maps version 6.3. So Bing Maps, just like Google Maps or other libraries, something that you would include in your application. You'd put a script tag and it would load it, and then you're actually giving that third party. Oh, I'm not too about that guy. The ability. Sorry. Oh, thank you. You're giving that library, ability to access code in your web page, and you're basically trusting them to behave appropriately. Does anyone actually see what's going on in this code that could be a problem? This is an interesting one.
Getting cursors and doing stuff with cursors.
I like the idea, but the sentiment and the energy, but no. So what's actually happening is that if you look carefully, this snippet of code is declaring two new variables in global scope, the I and the len, short for length variables. Because presumably whoever wrote this made the mistake of thinking that JavaScript has block scope and that they were defining a variable in a block and it wasn't going to bother anybody. But obviously you should all know better, and knowing that JavaScript uses function scope. And this actually leaks these variables into the global scope. So here's an example. So why would this be a problem? Who cares what the global definition of I is and length? Like whenever you're going to use it, you're probably going to reassign it and that sort of thing. And you'd override whatever this Bing Maps code did. Well, as it turns out, we were using the Closure compiler to minify our code. And what happened was the Closure compiler decided to save some bytes, and instead of using 4 bytes for the word true, it was going to assign it to the variable I, and assigned true to I. And everywhere in our code where we were going to reference the literal true, we now reference this variable I. So that means that once our application was running along, and then after we loaded Bing Maps, suddenly places where we were looking for true, we were getting the number 3. This was extremely hard to figure out where this was coming from. We certainly didn't know it was Bing Maps at first, but then eventually we tracked it down. And so this leads to kind of the basic problem of how do you load code from another website and protect your own code to make sure that variables don't leak out of scope and that sort of thing. So most people would say, oh, that's simple. Like all I need to do is load my code inside what a lot of people refer to as an immediate function. So a function that executes immediately, basically giving all of your code a fresh scope, protecting it from all the code loaded from another page. So normally that is definitely sufficient, absolutely the right way to go. The problem is now what happens if you have a lot of code, and so much code, that you need to break it up into modules. So by modules, I mean you take all of your code, you glob it into one file, and then you actually carve it up into bits that can be loaded dynamically. So for example, an application like Gmail, where you might have some core libraries, like say string and array utilities, that's one cluster of JavaScript that you want to load initially, and then depending on what the user does, you might want to dynamically load other JavaScript tags. So if they go to the inbox, you might want to load logic that's specific to that. If they go to settings, load logic that's specific to that. In that way, you basically can improve the startup time of your application. You're not penalizing the user for pulling down a bunch of code for things that they don't use. So this is a popular technique, a fairly popular technique to improve speed. But the problem is that if you think back to this, if you loaded every file, every module inside of its own immediate function, then you'd have this problem where code loaded in this module can't talk to code loaded in this module. They don't share a scope anymore. So the problem is that you want your modules to share scope, but you don't want to share scope with Microsoft. So what are you to do? What are your options? So there's a few ways right now that people load modules. So one is you load each module via its own script tag. You just do an append child. Every time you want to load another clump of JavaScript, you just add it. One of the nice things about this approach is that you can load your code from a CDN, a content delivery network. So this is popular because for your static resources, if you send them off to Akamai or someone like that, they have data centers around the world. Your app should be able to load a lot faster. So this is a pretty common way that people load JavaScript. But the problem is that any code that you load in this way, it's going to all operate in the global scope. So now we're going to have this come back to our problem where JavaScript that we load from Bing Maps could theoretically interfere with our code. A second technique is also, if the code is on the same domain, you could make an XHR, fetch the code as a string, and then just eval it. This you can't even do in an immediate function because when you call eval, it's either going to work in the function scope in which you're calling it or in the global scope. Either case, it's not going to work at this module scope that we don't actually have yet, but is the type of thing that we want. Also, just as a minor problem with this, also the JavaScript has to be on the same domain, so probably not usable with a content delivery network. And also, it can't be parsed as it's downloaded, so it's not as fast as, say, when you loaded something via a script tag. And the third option, which is a little bit better, is to load the JavaScript in an iframe. And so if you load all the JavaScript that you care about, that you want to be specific to your modules, you could create an iframe. You could basically create a new environment where only your JavaScript is loaded, and it can talk to each other, and it's effectively sandbox from the other libraries that you load in the top level frame. The drawback to this is that it's just kind of complicated, and that when you do things like load JavaScript in an iframe, when you refer to the document, you're referring it to that iframe, and you're not referring it into the page where your application most likely lives. So you can do some like jiggering to make sure that you use the right variable in the right spot, but it's pain, and it could also be error prone. So of these three solutions, none of them are really satisfying. They all have drawbacks. So fortunately, there is a workaround, and it involves using the hated with keyword. So this is the way this technique works is that it's similar to the immediate function, but you wrap your code in a function, and what you do is initially you create a scope. So this variable, this is an object literal, and this is going to function basically as the scope that we want to share between all modules as they are loaded. And we wrap our code in an immediate function, and inside that immediate function, the top level thing is a with block, and it takes the module scope as an argument, basically just so that we can alias it to a shorter local variable, so that in the page it's something unusual or unlikely to collide, but inside our function we can use a short name like A. So we pass it in, and then we just do with that scope. And then when we do assignments, top-level assignments, like var I equals true, instead of doing var I equals true, we do at least the top-level assignments inside our module code. We assign them directly on the object that we are passing to with. So you notice that here, the assignment is on A, so it's directly on the scope object that we've passed in. However, once you do that, all your uses of that variable don't need to be prefixed with A anymore. If you had to prefix it with A everywhere, this would be extremely tedious, but you actually don't have to, because what's happening is that when this alert statement executes, goes up the scope chain to get resolved, and it actually gets resolved on the object that was passed to width, which is A, or this module scope variable that we created. And so basically, every module that you load, which now you can do via a script tag, you have basically this, you have the exact same thing as this, except this declaration at the top, because this is going to be a global that actually is shared. And then every module will just call its function and take module scope and pass it in. So the one problem that you might notice is that, or your complaint might be, I don't really want to write my code like this. And I agree that you shouldn't write your code like that. It'd be very tedious. It wouldn't be portable across different use cases. And so fortunately, you don't have to. So there's two transformations that you need to do to your code. And I'll show you how to do them with the Clojure compiler. So basically, the two things that happen is that your function statements, so function f, this style, has to get redefined into the function expression style. So this is the style that's espoused in JavaScript, the good parts, and other places. So some of you may note that there actually is a behavioral difference when you do this type of transformation. That has to do only if you use function hoisting. In my experience, that's usually not an issue. It's a feature of the language that very few people use. So this transformation is basically fairly safe and straightforward. So this is the first transformation that you have to do, basically to prevent the function from getting hoisted outside the with block. And the second transformation, this one's a little stranger. So in this part, you need to make sure that all the assignments are done on what the shared scope variable is going to be across your modules. So, so if you have assignments, so normally your code, if it were just var x, and then y equals z equals 5, or another var declaration where you're defining it in terms of itself. Basically on the right side, normally if you just said var x, you wouldn't have to do an explicit assignment on the right. But to use this technique, you need to assign it to undefined. Because if this global scope object, A, doesn't have a slot or a property, so to speak, for x, then when you read it, it's actually going to go outside the with block. So basically, that's why all the initializations, or all the variables, top-level variables in your module that you're going to use have to be defined or have some definition on the global scope object. So you can see here, these are the basic types of transformations that you need to do, is or prefix things with whatever your local variable that you're going to pass to with is going to be. So we can see we assign x to undefined, and we also define a, like w, define it on a, define it in terms of itself. And now these things will behave the same if a is passed in. So again, this would be very tedious if you were expected to do all of this by hand. Fortunately, this is where the Clojure compiler comes in. So if you're not familiar with it, the Clojure compiler is a whole program optimizing compiler from Google. That means it reads in all of the code of your program, of your JavaScript, and compiles it all together at once. So it can do whole program analysis. So it could find, for a function, it could find all the call sites and that sort of thing, which is part of what makes this technique possible. So there's two compiler passes that you need to run. So basically, these two compiler passes take care of these two transformations that need to be done. So you write your JavaScript as you always normally would, but this is just an extra setting that you can enable when you compile your JavaScript. So these passes have not been upstreamed into the Clojure compiler yet, but that's in the process. I've built a build tool for Clojure called Plover, and that's open source. It's available on Google Code, and it has all the logic for these compiler passes. It's actually not that difficult if someone wanted to port it to another compiler. Perhaps most interestingly, most people are afraid, does this really work, or is this just some sort of toy exercise in JavaScript transformations? And I can assure you that it is not. I was formerly at Yext, and it's and there we built excuse me, a web application. It's over 100,000 lines of code, had to run on IE6 and up. We actually carved our code up into 25 modules to reduce the initial load size and let people pick from the pieces that they needed to when using the application. to dynamically load modules. And we did not witness any problems using this technique. So it is definitely much more than a toy and has been used at scale. The one other outstanding question is just that of speed, since most detractors from width often claim that it's going to adversely affect your runtime performance. So I have not done any sort of benchmarking yet. However, we did not observe any problems when running it. Yeah?
I recently did some benchmarking that observed what we did tomorrow. And my conclusion was that the time loop, which is accessing its loop variables through, is about 100 times slower than normal local scope things. So depending on what you're doing, it might speed up.
Yeah. I mean, so you said 100 times slower in a tight loop.
Yeah, it's accessing loop iteration variable through a little bit, so it has to do a little technical analysis.
Okay. Yeah. So I mean, so that's and part of that problem, though, I would say, is that there's what JavaScript interpreters do today, and then there's what we want them to be able to do. Obviously, recently with things like V8, we've seen interpreters get a lot faster. So I'm not really certain if there's actually a fundamental limit in width, or really just that people have not looked at optimizing it very much yet. Obviously, it's somewhat outcast in ES, or it is outlawed by ES5 strict. So obviously, that makes it less popular to work on. Yeah.
I think the reason why it's reviled so much is that it's very hard to compile. That's why people do it. So I'm not sure. I mean, there are
yeah, well, so this technique is a little different because it's using width at the very top as opposed to very deep in the AST. So I'm not sure that many people have been using it or looking at it this way before, but I could be wrong about that.
I would say that makes it worse because you're having this scope change for a whole code. So it's making you have to
yeah. Well, it's definitely worth measuring to be certain. But talking to other people, it's still in JavaScript, and compared to say DOM accesses or that sort of thing, it's still actually maybe very cheap. It's hard to say without actually testing it out.
One question: is there any way to differentiate, since you're using an automated system, to kind of convert VARs over to like the property access on the kind of that shared module object? Is there a way to differentiate between like kind of like module context variables and then strictly local, like a var, like, hey, I don't need this to be in the module?
Oh, yeah. Yeah, so I guess I don't really demonstrate it here, but the question was, is this transformation done for all var declarations or only ones at the top level? And so the answer is that it's only done for ones at the top level. So inside a function scope, you don't need to.
No, but even at the very top level, in your like, say you've got like 25 modules across your entire application. Each one is its own closure. If you don't need like a particular, you want a variable that's local to that closure. It doesn't need to be local to like all of your modules. Like, can you have like closure level variables in addition to module level variables?
Yeah, I think you can do that. I don't believe the way that the passes are written right now do that, because I don't think they take what's called cross-code motion into account. Basically, code gets moved to the least common ancestor of where it's used. But I think that is definitely possible, and that's true. That would reduce the number of aliases that you'd have to create.
Yeah.
That's a good question, though. Let me see. Are there any other questions while I'm fielding questions on the technique? Okay. So this is just, to sum up, this was actually done by my colleague at Yext, Ilya Merkin. He basically, we got stung by this Bing Maps problem, and he tracked it down, how I mysteriously became 3. And it turned out that this protected us from arbitrary third-party modules, but also we discovered that there are certain web proxies that also seem to inject JavaScript into our page. We weren't really sure why that was happening, but this also adds a level of protection around that sort of thing. So I realized that because of all the things that have been written about with in the past, like it may be hard to accept that this is actually a really good solution to this type of problem. But I certainly encourage you to take a look. And I think that if this becomes a more popular technique, then things can be optimized. Things that are slow today are not necessarily going to be the things that are slow tomorrow. So I encourage you to take a look at the code and contact me if you want more information. Thank you.